Let's go ahead and use the power rule and product rule to find derivatives of some functions. Let's take a look at the power rule first. Suppose you have a function of the form x to some power n, like that, and you want to take its derivative. That's the derivative notation. So the derivative of such function using the power rule would be you bring down the power and subtract 1 from that power. That will be the power rule. We can prove this formula by using the limit definition of the derivative, but we'll leave that for another day. Let's get to the calculation. So for these 4 examples, we're going to find their derivatives by using the power rule. So for the first problem, we want to find y prime. So let's go ahead and do that. So I see that I have 5x as my function. So by using the power rule, I bring down the power. The power is 1. So that's really 5 times 1 times x to the power 1 minus 1, which is 0. And then the derivative of a constant, that's going to be 0. So this would give us simply 5 times x to the 0, or simply 5. So the first derivative of this function is simply 5. Now let's take a look at the next problem. We're looking at number 2. So f prime of x, that's the derivative notation. Using the power rule for the first term, we bring down the power, we subtract 1 from the power. That's 3x, 3 minus 1, that's 2. Then we go to the next term. We take the derivative of negative 4x, that simply be negative 4. X to the 0th power is 1. And finally, if I take the derivative of a constant, that's 0. So my derivative is simply 3x squared minus 4. For the next problem, h of x, we're looking for h prime. That's the first derivative of h. So I can, well, here I can't really go directly because of the product right here. So I would have to pause and find h in a different notation first, and then we can differentiate. So we're going to have to expand the terms first. So you distribute x times 2x and x times 3x. That's 2x squared. And then x times 3, that's 3x. Then move on to the next term and distribute negative 4x minus 6. And now we can combine like terms. So h of x is really 2x squared. These are like terms. That's minus x minus 6. So that is h of x. Now that it looks like in the power form, we can find its derivative. So h prime of x, using the power rule, the derivative of this is going to be 4x. We bring down the power, subtract 1 from the power, minus derivative of that, that's simply going to be 1. And derivative of negative 6 is 0. So that is our derivative for h of x. And the last problem is this one right here. I'm just going to move it down here so we have more space for it. Now, before I work this out, I do have to simplify just like the previous problem. So you want to rewrite these as an exponent. So let's go ahead and do that. So we know this can be written as x times x to the 1/2 power plus, now this is 1 over square root of x, which is 1 over x to the 1/2 power. And I can simply bring that on top and make it into a negative exponent. So I can rewrite it as x to the negative 1/2 power like that. And then I can distribute the x to all of these terms. So my function y is simply x to the, so I'm doing 1 plus, this is a 1 power, 1 plus 1/2, that's 3/2, plus, and then 1 plus a negative 1/2, that's 1/2. So that is the function y. Now we can take its derivative. So take its derivative respect to x. Here I use the power rule. We bring down the power, that's 3/2. X to the power, we subtract 1 from the power, so that would be 1/2. Plus, again, we bring down the power 1/2, x, subtract 1 from the power, that'll be minus 1/2. And we can rewrite this as 3/2 a square root of x plus 1/2 square root of x. So that will be another way to write our answer. Okay, so I hope the power rule is making sense to you. Now let's go ahead and see how to use the product rule. So suppose we want to now differentiate functions that are product of another functions. So for the product rule of differentiation, you might have a function expressed as multiplication of two functions, f and g. So the derivative of big F is simply the derivative of the first, keep the second, plus you keep the first, differentiate the second. So that will be the product rule for product of two functions. So let me show you how to use it by using a function. Let's say you have your function y is given as x plus e to the x times x minus 4. Now you can expand this and then find the derivative, but we're going to simply use the product rule so we understand how to use it. Suppose this is your f and this is your g, that means y prime will simply be the derivative of f, keep g, plus keep f, differentiate g. And then if I substitute these into these given functions, I differentiate f, so this is f, take its derivative of x is 1, and derivative of e to the x is simply e to the x. That's for the first. Now you keep the second, x squared minus 4, plus now you keep the first function and differentiate the second function. So I keep x plus e to the x, and I differentiate the second. Now I differentiate this, derivative of x squared, that's 2x, derivative of 4 is 0. So that will be it. And if you want, you can clear things up, a little bit of algebra. So here's another example I would like to work out. We're going to use the product rule to find the derivative. So think of as this is your first function, let's call it f, and this is another function, g. So y prime will simply be the derivative of the first, keep the second, plus we keep the first, differentiate the second. So this would simply be, well, derivative of 10x to the fourth will be 10 times 4x to the third. We keep the second, plus now we keep the first and differentiate the second. Derivative of e to the x is a to the x. And by clearing things up, y prime is equal to 40x cubed e to the x plus 10x to the fourth e to the x. So that would be our y prime for this function. And you can factor things out, make it look different, but the calculus part is completed.